What's poppin', dogs? Mr. Allen here with some polynomial long division in this video, and we have a beast, a quartic polynomial that we're going to deal with here. And I've written it up in a couple different ways. So we have given that p of x equals 2x to the fourth plus 5x cubed plus 7x squared plus 16x plus 15, and g of x equals 2x plus 3. Find p of x divided by g of x. Sometimes it's written like that. Sometimes they set it up ready to rock and roll with long division. Sometimes they'll write this guy here and then a little division sign and then the 2x plus 3, which you're dividing by. In any event, we're going to go through the same steps of polynomial long division. And I would suggest a handful of colors here to keep yourself organized through this process. All right? I'm going to do a lot of underlining, changing of colors, going through all these different steps. So the first thing, I'm always going to focus on that 2x right there. Okay, we're going to use that a bunch through this process. And this is going to be paired up this time with the 2x to the fourth, the first term right there. And what we're going to do is divide those two. Okay, so 2x to the fourth divided by 2x, what is that? Well, I'm going to do some side math right over here throughout this process in different colors. So I have 2x to the fourth divided by 2x. Now, you might be able to do it in your head, but if not, write it down off to the side until you get the hang of this, okay? Well, the 2's cancel. X to the fourth divided by x to the first would be x to the third. So x to the third is going to go right up here. Now, some teachers want you to line it up above the matching degree. I don't find that necessary in this part of the whole process, but whatever your teacher wants, do that, all right? So now that I have the x cubed, I'm going to multiply through to these two terms and write them below their like terms. That's where the lineup is really, really important, okay? So x cubed times 2x is 2x to the fourth. Those two will always match. If they don't, you did something wrong. Then we have x cubed times 3. That's going to give me positive 3x cubed. Okay. Now the next thing here is we're going to subtract these two from the two above and write the result right here, and we're going to repeat the process. But I've got a little rhyme for this one to help us remember the subtraction, because it's often a mistake that kids make in forgetting to distribute the negative to both. Okay, so we're going to be subtracting both of these from both of those. So I like to draw my line, change the sign, subtract them now. We end up with, let's see here, that'd be 2x cubed. Then I drop this next term here, plus 7x squared. I'm going to start my process over again. These two right here, they cancel, right? They always will cancel. They're always going to cancel out, or you did something wrong, all right? So we subtract these two, the results down here after dropping down the next term. We're going to start the process over again with a different color. I'll use blue this time. I'm still going to be working with this 2x, but I'm also going to be working with this guy right here. So it's a new term that we're dealing with. So 2x cubed divided by 2x. I'm going to do it off the side here so we just keep the color coding going. You don't have to do this side math if you don't need to. That's totally fine. I got 2x cubed divided by 2x, and I'm left with x squared. Pop that guy right up here. Then we'll multiply through just like we did last time. So x squared times 2x is 2x cubed. Look at that. They match up. They always will, or you did something wrong. X squared times 3 gives me positive 3x squared. Now it's time to subtract. So I'm going to grab the other color, draw my line, change the sign. These two cancel. They always will. This one here, we're going to have 7 minus 3. We're going to get 4x squared. Next move, drop it like it's hot. Bring the 16x down. We're going to start the process over. So it's the same 3 or 4 steps, whatever, count them up, over and over again. There's definitely room for errors. There's a lot of algebra going on here. Any one mistake and you're screwed, okay? So you got to be really careful not to make any mistakes. Hopefully I haven't made any mistakes so far. It does happen, though, guys. I am human. I do make mistakes. Hopefully we're all good. All right, new color, green this time. I'm looking at my 2x still. Always going to be looking at that first guy, but now it's paired up with that one. A little side math over here. I got 4x squared divided by 2x. This time I have 4 divided by 2 is 2. X squared divided by x to the first is just x. So plus 2x. And then we're going to multiply it through. 2x times 2x. 4x squared. These two match. They always will. Or you did something wrong, because they got to cancel out when we draw the line and change the sign. 2x times 3 is 6x. Then I'm going to draw my line, change the sign so I remember to subtract all the way through, especially when you start dealing with like quadratics here. You got 3 terms. You got to distribute all through there. I like to draw the line, change the sign. Shout out to my cooperating teacher from student teaching many moons ago, Andy Lucas. He taught me that rhyme. All right, these two cancel. They always will. 16 minus 6 is 10x. One more time, drop it like it's hot, plus 15. Repeat the process one last time. Let's see, I'm running out of colors. It's neon. It kind of looks like the green, but otherwise I'm out of them, all right? So actually, wait, hold on. I have purple one, but it's a little squeaky. It's a little squeaky. We'll deal with it. So we're going to work with, once again, this guy here and the 10x, okay? So over on the side here, we got 10x divided by 2x. That's 5. So plus 5 right here. Then we're going to multiply it through, just like we did before. 5 times 2x is 10x. 5 times 3 is 15. Bring out the orange guy, draw my line, change the sign, and I end up with 0 for my remainder. Okay. So what does that all mean exactly? Like, what's my answer? What does everything mean? Well, P of x divided by G of x is this multicolored wonderfulness that we have up top here, okay? So this is my answer that we're looking for. Final answer there. No remainder, so we don't add anything to that. I will do some problems where there is a remainder, and you'd say plus whatever the remainder is over the 2x plus 3. But I do want to talk about a few other things here with this problem that could be asked on, say, like a test or a quiz or whatever, because we ask different style questions, right? So here's one. If I wrote, and actually let me get some of this stuff. No, we're okay. We're okay. I can fit it right here. If I wrote this, P of x equals 2x plus 3 times x cubed plus x squared plus 2x plus 5. Is that a true statement? Is this right here equivalent to the P of x that we have written up there, that whole quartic monstrosity? Well, yeah. Right, well, one, you could multiply it out and see 2x times x cubed is going to give you 2x to the fourth. 2x times x squared is going to give you 2x to the third, but then I'll have another 3x to the third gives me the 5x to the third when I combine like all that stuff. But let's think about it without multiplying it out. I just took this guy here. I divided out the 2x plus 3 with no remainder. Therefore, this is a factor of this larger polynomial here. Factors, right? Parentheses, that looks familiar with factors. So I could write P of x in this way. And that'd be a great select all that apply type of question. Like, oh, if P of x divided by G of x equals this, then P of x equals that, right? And that would be true. How about this? What if I wrote, and I'll do a different color here, P of x divided by 2x plus 3 equals x cubed plus x squared plus 2x plus 5. Would that be true? Yeah, that's exactly what was written here, except for I popped the 2x plus 3 right there, right? Or if we gave you this, you could still be able to identify that those two are the same. And I want to make sure that that doesn't bleed into the long division there, right? Okay, so another way of writing it. Now, one last thing that I want to ask here. One last thing. What about this? Is that true? Where did I come up with the negative 3 over 2? Take a look at this guy right here. If I set 2x plus 3 equal to 0, and I subtract 3 divided by 2, I get x equals negative 3 over 2. So if I were to substitute in negative 3 over 2 into P of x, whether it's this guy, that guy, whatever, would it equal 0? It's an interesting question. Well, I think it's easier to identify here with the pink one, because if I plug in negative 3 over 2 right here, I'm going to get negative 6 over 2, which is negative 3 plus 3 is 0. 0 times anything is 0. So yes, that would be true as well. Again, select all that apply. Perhaps you could have this, this, and this as 3 correct answers there that you'd have to select that would all be true statements. things, okay? So not only do you have to know how to do the whole process of long division, being able to answer different questions is also important. All right, so essentially what we're doing here is we're plugging in one of our zeros into p of x, which I know is a 0 because I just divided it out, and the remainder was 0, so it's a factor of it. So if I plug in that x value, it's going to give me 0. All right. That's pretty dope, you guys. That's a lot of fun colors there. Definitely need to stay organized when it comes to long division. This is the main process that you guys need to know. I just threw in some random test idea questions and stuff like that because I think a lot of times you're like, I know my stuff, but then when I get to the test, I didn't get it right. Well, there are different weird questions that can be asked on either a standardized test or even just the multiple choice section of your math test. Be prepared for things like that. All right. So hope that helps you guys. If you have any questions or anything like that, feel free to drop them in the comments or ask for another type of video. Happy to make it. Otherwise, have a fantastic day. Don't forget to like and subscribe and spread the word. Peace.